Hi, this is Mr. Beckstrom, and today I want to take a look at a problem from section 3.4. This is building quadratic models from descriptions. So the problem says Daniel has 3,000 feet of fencing and wants to enclose a rectangular plot that borders his house. This side is his house over here. If Daniel does not want fence on the side along the house, what is the largest area that can be enclosed? So we want to kind of maximize this area here. Now remember, when it says this is a rectangular plot, that means these fences here need to meet at right angles to form a rectangle, and we're trying to maximize this area. So this problem has a few parts. So the first thing I want to do is I want to say, well, what is the area of a rectangle? The area is length times width. So if I call this side x, since this is opposite the rectangle, that has to be the same size, so that's x as well. And we don't know what this side's going to be yet, so we'll call this y. So the area of this rectangle is going to be x times y. And you can call it anything you want. That's just what I called it. Now, if I'm going to try to make a quadratic in terms of one of these variables and use my dependent variable as area so we can kind of maximize it, then we want to replace one of these two variables so it's all the same on this side. So one way we can do that is we can look at another formula that works for the rectangle, and that would be the perimeter. So if I, off to the side here, I say the perimeter of this is equal to, now that's just the distance around the fence. Now it's not going to be 2x plus 2y because we only have one y side. So in this case, it's going to be 2x plus y. All right, and we know what the perimeter is going to be here. That's 3,000. So this is 3,000 is equal to 2x plus y. Now in this case here, I'm going to go ahead and solve for y because it's just a little bit easier. All I have to do is subtract 2x from both sides, and then I'm going to flip it around here. So in this case, y is going to be equal to negative 2x. That's subtracting 2x from both sides, plus 3,000. All right, now that I have this equation solved for y, I can go ahead and substitute it back in here for this y. And that's going to give me a is equal to x times, and I can put this whole thing in here, negative 2x plus 3,000. And I'm a little short on space here, but I think we're going to be okay. So this is, all I did here was replace this y with what I had over here from the perimeter. And I used the perimeter because they told me how much fencing I needed, and that corresponds directly with perimeter. So now if I distribute this out, I'm going to get a is equal to, this is going to be negative 2x squared when I multiply the x and the negative 2x, and this is going to be x times 3,000 is plus 3,000x. X. All right, and now I have a quadratic, and if I want to maximize this here, remember that's only going to happen. Think about what a parabola is. This is a quadratic, which is a parabola. It's a downward facing parabola, so it's going to be looking like this, and the a corresponds to my y value. So where do I have the highest y value, or in this case the area? It's going to be right here at my vertex. So now I have the formula to find the x value of my vertex, and that's just going to be x is equal to negative b all over 2a. And that'll find me my x value of this vertex here for this value right there. So this is going to be x is equal to negative. My b here, that's the coefficient that's in front of my x value, my x to the first value. So that's going to be 3,000 all over 2a. So that's 2 times negative 2. My a is my coefficient in front of my x squared term. So that's going to be all over negative 4. So the two negatives will cancel out. And I'll have a positive, and it'll be 3,000 divided by 4, which is 750. 750. And remember, we're talking about feet here. So this is telling me right now that in order to maximize the area here, my x value should be 750 feet. 750 feet. And now I need to find my y value. In order to find my y value, I can plug this x value into any of these formulas here that have both the x and the y. So I'm going to do it over here. So I'm going to kind of take this one down here and say 3,000 is equal to 2 times 750 plus y. Now I can solve for y, and if I do that, y is equal to, that's going to be 3,000 minus 1,500, which is 1,500 feet. All right, so this y here, and I don't really have space for it, but I'll kind of put it over here, is 1,500 feet. So finally, to answer this question, I need to find the area of the maximum rectangle with 3,000 feet of fencing. Now I can go ahead and pull up my calculator and just say 750 times 1,500. So 750 times 1,500. And I get pretty big number, 1,125,000. All right, so the area is equal to 1,125,000 square feet. I can just write that as feet squared. And we are done. If you have any questions, let me know, and I hope you have a great rest of your week. Thank you.